All right, tonight what we're going to be talking about is how to predict a product when you're just given the reactants. And there are some hints that you want to kind of memorize or be very familiar with before you actually start predicting products, and then always remember them while you are actually predicting products. The first, which is key, is to remember look for the combustion. As with identifying, always look for that combustion reaction first. If it is not a combustion reaction, then label your elements and your compounds. You can either literally do that or figuratively do that and think about it in your head. The third step is then to identify the type of reaction, because that will help you predict your products. Okay? So after you've predicted the products, once you realize what's going to happen, you need to realize that if you ever create an element, remember you have to worry about the Hunkelbriefs, just like when we were writing out the equation. And if you created a new compound, you're going to have to worry about CCC, or the compounds, crisscross, and charges. After you've created that whole new, or you've written out the balance or the chemical reaction, then the last thing you're going to need to do is balance it so that you follow, once again, the law of conservation of mass. All right, so let's go straight at it. So the first one that we're going to do is look for if it's a combustion reaction. So we're going to look for a hydrocarbon plus oxygen. In this case, we don't have a hydrocarbon or oxygen, so we're good to go on that. So we know that it's not a combustion reaction. So next what I'm going to do is I'm going to label whether it's an element or a compound. So I have two compounds that are seen on here. As you look on your types of reactions, anytime you have two compounds, you're going to be doing a double replacement reaction. What is going to happen with that is you are going to switch your cations. So if I look at my cations are my first ones. They are the positively charged ones, and I am going to literally swap them. So where H was, Ca will be, and where Ca was, H will be. So I'm literally going to put H and then CO3. And then now where H was, I'm going to put Ca, so it'll go Ca, Cl. As with everything, with dealing with chemical compounds, you always need to write the positively charged thing first and then the negatively charged. Basically, it will already be written for you on the reactant side. All you have to do then is switch them. Now, the key that a lot of students forget is that they carry over subscripts or they don't worry about charges. And that is a huge, 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 huge problem. So make sure as soon as you've created your compounds for this one, you worry about your different things that you need to. In this case, we haven't created any elements, so we don't have to worry about Hunkelbriefs, but we have created two new compounds, so we're going to have to worry about charges. Hydrogen's charge is a +1. Carbonates is a -2. So when I crisscross that, I get H2CO3. Ca's charge is a +2. Cl's charge is a -1. So when we crisscross those, we get CaCl2. Okay, and the very last step is to try to balance it. So remember, we can never, ever, 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 ever change the compounds themselves. All we can do is change the coefficients. So in order to balance this reaction, we are going to need to put a 2 in front of the HCl. All right, there you go. There's the first one. The next one that we're going to do is number 2. And once again, as with everything, you have to first identify whether there is a combustion reaction or not. Looking at this, I actually see a hydrocarbon here, and I know that I'm adding it with oxygen, so immediately I know and can identify this as a combustion reaction. So as soon as you've identified a combustion reaction, you automatically know the products. What are those products? Well, they are 100% of the time CO2 plus H2O. Okay, it will never, ever, 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 ever change. So combustion reactions are actually the best ones to be given on a test as far as a student goes, because you always know the products. You never have to worry about charges or anything like that. The only problem that a lot of students struggle with is with balancing this reaction. And so all you need to do, though, is for this particular one, this is a relatively easy combustion reaction. You're going to put a 2 in front of this one, in front of the H2O, which makes you have the 2 oxygen, and then you're going to need to put a 2 in front of this oxygen, so that you have 4 oxygens on the left, 4 oxygens on the right, 1 carbon, 4 hydrogens on the left, 4 hydrogens on the right. All right, the next one that you're going to be doing is the MgBr2. Well, all I see is one compound, so I don't see a hydrocarbon plus oxygen. And as I've just stated, this is one compound. So what's the only thing one compound can do? Well, that would be a decomposition reaction. And a decomposition reaction, remember, is when you have one compound and it's going to break up into its individual elements. So what I'm going to have is Mg plus Br. Do not carry over this subscript for Br because you are creating an entirely new substance. The only reason why they had a 2 on the left-hand side or the reactant side was because in this compound, Mg has a +2 charge, Br had a -1, so when you crisscrossed it, you got MgBr2. When you create an element, the only thing you ever have to worry about is if it is a Hänkelbrith or a Hoberfinkel. So if it is a Hänkelbrith, then you are going to need to put a 2. If it is not, then you're going to leave it. So Mg is not one of the Hänkelbriths, but Br is. So I'm going to need to put a 2 as a subscript. Now I'm going to rebalance it, and I notice I've got 1 Mg on the left, I have 1 Mg on the right, I have 2 Brs on the left, I have 2 Brs on the right, so I am already good to go. The next one that I'm going to be doing is Na plus O2 or sodium plus oxygen. So first, once again, you're going to want to figure out if it's a hydrocarbon being added to an oxygen. I do have that oxygen, but I do not have that hydrocarbon, so I know that this is not a combustion reaction. So the next thing that I'm going to do is label my elements and compounds. Sodium is an element, oxygen is an element. So what this is going to be is looking at my 5 types of reactions. This will be a synthesis or a combination reaction. The products of those, when you are expected to predict the products, is going to be a compound. So I'm going to need to smush them together. Now it's really, really important that when you are ever making a new compound that you always put the positively charged thing first, or the metal first. So in this case, I'm going to write Na, and then I'm going to write O. Notice that I did not, I'm going to get rid of that. That's a really bad A. Notice that I did not carry over that 2 for that oxygen, and the reason why is because whenever you create something new, you do not carry over the subscripts. Once again, you do not carry over the subscripts. So I need to worry about, I made a new compound, so I'm going to have to worry about my CCC. So I've already done my compound. Now I need to worry about my charges. Sodium's charge, when it is in an ionic compound, is a +1. Oxygen is a -2. And then my last C is going to be crisscross. So I'm going to get Na2O. Okay. So now I need to worry about my final thing, which is balancing the chemical reaction. So I have two sodiums on the right, so I need to put a 2 in front of the one on the left. And so now by doing that, I need to balance my oxygens. So I put a 2 in front of the Na2O, which balances out my oxygens, but then it messes up with my sodium count. So then I need to put a 4 now in front of my sodium. And that absolutely is fine if you have to readjust along the way in order to make all of your compounds work. So now I have 4 sodiums on the left, I have 4 sodiums on the right. I have 2 oxygens on the left, 2 oxygens on the right, so I am good to go. Alright, the final one is lead 2 nitrate or lead nitrate plus sodium. So what I'm going to need to do is first again identify whether there is a combustion reaction going on. I do not have a hydrocarbon nor an oxygen, so I'm going to move on from that and I'm going to start labeling. So I have a compound here and I have an element here. So the only one that has a compound plus an element is going to be a single replacement reaction. In the single replacement reactions, the element by itself, so in this case sodium, will kick out its like in the compound. So sodium is a metal, so it will kick out a metal. Okay? You kick out your like. If you're a metal, you kick out a metal. If you're a non-metal, you kick out a non-metal. So in this case, Na is going to go exactly where NO3 was, or I mean where PB was. So it's going to be partnered up with NO3. So I've got NaNO3. Once again, remember that you do not carry over the subscripts. The only reason why I carried over that 3 is because it is nitrate. You can't change what the polyatomic ion is. You can just change how many you have of them. In this case, we had 2. In this case, we don't know how many we need right now. So I did create a new compound, so what I'm going to need to worry about with this guy is its charges. So Na's charge is a +1, nitrates is a -1, so when we crisscross, we already reduce, and it's 1 and 1. Now, because I kicked out the lead, it is going to be an element by itself. So we're going to do plus Pb. Remember, the only thing you ever have to worry about when an element is by itself is if it is one of those Honkelbriefs. And in this case, lead is not one of the Honkelbriefs, so I do not need to worry about putting a 2, making it a diatomic molecule, so I will just leave it like that. My final thing that I'm going to need to do is I'm going to need to balance it. So I'm going to look at my general counts. I have 2 nitrates on the left, so I'm going to put a 2 in front of my NaNO3, which adjusted then my Na count to 2, so I'm going to put a 2 in front of my Na, and now I have 1 lead, 2 nitrates, 2 nitrates, 2 sodiums, and 2 sodiums, so I am good to go. By the way, I forgot, I believe, to tell you that because you have a compound plus an element, this will be a single replacement or a single displacement reaction. All right, hopefully you kind of have a basic understanding of how to predict products, and we'll be practicing more during class.